Hi, this is lesson 2.6, solving absolute value inequalities. You should be on page 88. In this lesson, you will learn how to solve an absolute value inequality, and you will learn how to use an absolute value inequality to solve a real-life problem. Let's talk about solving an absolute value inequality. First of all, we got to know what it is. An absolute value inequality is an inequality that contains an absolute value expression. For example, both of those are absolute value inequalities. Can you see how there's an absolute value in an inequality statement? Recall that the absolute value of x equals 2 means the distance between x and 2. Absolute values are always going to produce positives because distance are always positive. One other thing to remember, absolute value equations, this is from chapter 1, always produce two solutions. That's going to be an important factor today. Now, when we have absolute value inequalities, an inequality like x less than 2 means the distance between x and 0 is less than 2. In other words, I'm looking for what values of x have a distance from 0 that's less than 2. Well, you can see a picture of that below here. Okay? Here are the values of x that are less than 2 away from 0, like numbers like -1, 0, 1.5, -1.5. Those are the values that are less than 2 away from 0. And then, here's a second potential possibility. The inequality absolute value of x is greater than 2. That means the distance between x and 0 is larger or greater than 2. So like, for example, 3 would meet that condition. Or what about -5? Isn't -5 more than 2 away from 0? Here is a picture of all the values that could meet that condition. Core concept. Let's talk about how we solve an absolute value inequality. And this stuff you should get in your notes because some of us struggled solving absolute value equations in chapter 1. I'm going to go through those steps again right now, and we have to correct that or we're going to have issues in chapter 2. This stuff is a total review of lesson 1.4. First of all, you must isolate the absolute value on these questions first. If you do not, that's going to be a problem. Well, some of us in chapter 1 did not isolate absolute values first, and that screwed up our work. 2, you can expect 2 solution sets. Remember chapter 1. I had people on the chapter test that did not write 2 equations. They only wrote 1 and only had 1 solution and half the problems wrong. These have 2 solution sets. You need to solve 2 inequalities then. 3, when you write your second inequality, you will need to reverse the inequality symbol and change the sign of the number. And finally, this key concept box, I wrote out what this says down here, so I'm going to make sure you understand where this, what I'm writing, relates to up here. If you isolate the absolute value and you have a less than problem, that is an and problem. So let me highlight that up in the book. Do you see how they have the absolute value isolated and it says less than C? When the absolute value is isolated and you have a less than, that's an and problem. Now, and means something specific. We talked about this earlier in the chapter. If your mom says you must clean your room and do the dishes, that says something. It means you have to meet both conditions. And means all the conditions must be met. However, if you isolate the absolute value and you have a greater than symbol, that's an or problem. So if you look here, here's an absolute value isolated. It's greater than C. Do you notice greater than? That means it's or. That means only one of the conditions must be met. If mom says you must clean your room or do the dishes, You're probably a little bit happier about that because she's made it clear you only have to meet one of those conditions, not both. Okay? So when you solve, and versus or is important with the graphing. Let's talk about solving absolute value inequalities. And you notice for these questions, these are both going to be and problems because in both cases the absolute value is isolated and we have a less than. These are and. So here's what we need to do. Step one, is the absolute value isolated? And on this problem, yes it is. Okay. Step two, Step two, you have to write two inequalities. So you notice the book. They take this inequality and they just rewrite it. X plus 7 less than or equal to. Now the second inequality, right here, I'm circling it right here. You have to reverse the inequality and change the sign. So you notice the second inequality. They have a greater than equal now, and they change the sign from positive to negative 2. Okay, we just got to solve each of these. To get rid of plus 7, you take away 7. X is greater than or equal negative 9. Over here, you take away 7. X is less than or equal negative 5. This is an and question, which means you can write this as a triple inequality. Negative 9 less than or equal x less than or equal negative 5. So now let's go ahead and graph that. Now, and graphs normally, did you hear me? I didn't say all the time. I said normally, most of the time. It's going to be 2 points with the shading in between. So I'm looking for values of x that are greater than or equal to negative 9 and less than or equal negative 5 at the same time. These points in between meet both conditions. Like think about negative 8. It's bigger than negative 9, but at the same time it's less than negative 5. Okay? Part B, this problem. Absolute value of x minus 11 is less than 0. Now first of all, we got to think, doesn't less than 0 mean negative amounts? Can an absolute value produce something that's negative? No, it can't. That's why you look here. This problem would have no solution. An absolute value can't produce something that's a negative. I would like you to try. Pause the video and try these 3. Okay, we're back on this first problem. I have an absolute value isolated. It's a less than or equal to problem. Less than means and. So write your 2 inequalities. X less than or equal 3.5 and x would be, do you notice I reversed the inequality and I changed the sign. X greater than or equal negative 3.5. And problems I can write in a triple inequality format. And that means I can plot those 2 points and shade in between, which you see there. I plotted negative 3.5. I plotted positive 3.5. Do you notice I colored these in because the problem had equal? There was equals in there, and I'm shading in between. Let's go to question 2. This one says the absolute value of k minus 3 is less than negative 1. Let's think. Can an absolute value produce something less than negative 1? And I hope you're saying, well, that's not possible. Okay, well, that means there's no solution to this problem. Okay, absolute values can't produce something less than negative 1. So my graph would just be a blank number line. I can't graph anything. There's no solutions to it. And then number 3. The absolute value is isolated. So, step 1, write 2 inequalities. 2w minus 1 is less than 11. Just copy what you see. Now, for your second inequality, reverse the inequality and change the sign. 2w minus 1 is greater than negative 11. If you add 1 and divide by 2, w greater than negative 5, and over here, add 1, divide by 2, w less than 6. So there's my triple inequality, and problems can be written in triple inequality form. Ors can't. Let's go ahead and graph that. Negative 5 less than w less than 6. So I have an open circle at negative 5, a closed circle at 6, and I'm shading in between. This next group, those last problems we worked on were ands. Let's look at ors. Okay, so here are some or questions. We have an absolute value isolated greater than equal 5. Now the greater than tells me it is an or problem right away. I am going to write two inequalities. I'll copy this down, c minus 5 greater than equal 5. You notice, drop the absolute values. And then the second inequality, you notice how we reverse the inequality and we change the sign. Okay, let's solve them both. To get rid of minus 1, I have to plus 1, and I'd have c less than equal negative 4. And over here, when I plus 1 to each side, c is greater than equal 6. This is an or question. Now remember, the ors cannot be written in triple inequality form. So let's graph both of those. Here is c less than equal negative 4. And over here where I'm pointing, c greater than equal 6. Now remember, or means you must meet one condition. Let's try one of these. Let's try 10. Does the number 10 meet one of those conditions at least? Well, yeah, it does. It is bigger than 6. So it meets one condition. Okay, for this next one, absolute value of 10 minus m is greater than or equal negative 2. Now let's think for a second. Doesn't absolute values always produce positives? Let's write that in there. Think about that. If they always produce positives, won't absolute values always give me something that's going to be greater or equal to negative 2 if it's always producing positives? And I hope you're coming up with the answer of, yeah, well, I mean, I could never get a negative here. This is always going to give me positives. Okay? So with that in mind, since this always must give me a positive, I'm always going to get something that's greater than or equal to negative 2. So this is an example of a problem that would have all real numbers as a solution. In other words, you notice how they graphed they just shaded the entire number line. I can plug in anything for m, and it's going to get me something that's a positive, which is bigger than negative 2. Okay, this next one. Big deal for part C. And again, this is what we screwed up a lot in chapter 1. You must isolate the absolute value first. Do you notice the absolute value is not isolated right now? To isolate it, we have to add, or I misspoke, subtract one, I meant to say, from each side first. That will cancel here, and absolute value of 2x minus 5 times the 4 is greater than 20. Now, did you hear me say times the 4? To get rid of times 4, we got to divide each side by 4. So the 4's will cancel, and 2x minus 5 is greater than 5. Now, this is an OR problem. So we have OR, we have to write our two inequalities. So the first inequality, let me just highlight. You notice they're just copying the inequality down, and 2x minus 5 greater than 5. We're just dropping the absolute values. But the second inequality, look at it carefully. Do you notice how they reverse the inequality symbol and they change 5 to a negative? All right, from here it should be easy. To get rid of the minus 5, add 5 to each side. So here we get 2x is less than 0. Over here add 5, 2x is greater than 10. To get rid of times 2, you divide each side by 2, which you see here and here. Dividing by 2 cancels those out. X would be less than 0, or x would be greater than 5, and we can quickly graph it, and you see that here. Remember, only got to meet one condition. Like, let's pick 10, because you can see 10 would be a solution. Does 10 meet one of these conditions? It's OR. Yeah, it's greater than 5. I would like you to pause the video and quickly try these three. Okay, I'm back for the first question. X plus 3, absolute value greater than 8. This is an OR problem. We got to absolute value is isolated. We got to write two inequalities. Here's the first one. I'll have to write x plus 3 is greater than 8. Or, here's the second one, x plus 3 flip flip the inequality and change the sign. X plus 3 is less than negative 8. So take away 3 from each side, x would be greater than 5. Or, if I take away 3 from each side here, x would be less than negative 11. So now I have to graph, so I want the values that are greater than 5, there's 5 and greater, and less than negative 11. Negative 11 is way over here, open circle, and shading that way. So there would be a picture of that solution set. Okay, for number 5. First of all, the absolute value is not isolated, so I have to add 3 to each side, and I'm getting n plus 2 is greater than or equal, absolute value n plus 2, by the way, greater than or equal negative 3. Now, don't absolute values always have to give me positives? So I'm always going to get a positive here, so no matter what I put in here, I'm going to get a positive, and that's going to automatically be bigger than negative 3. This isn't an answer of all reals. I could plug anything for n, and this will produce a positive, which is always going to be bigger than or equal to negative 3. So let's go ahead and graph that. So that would just be me saying, hey, any value works, and I'm just shading my entire number line. There's any value I pick will work for that one. And then the final question for number 6, we must isolate the absolute value first. So add 7 to each side, which gives us 3 absolute value d plus 1 greater than or equal 6. Divide each side by 3. So d plus 1 absolute value would be greater than or equal 2. Now you can write your two inequalities. D plus 1 is greater than or equal 2, or d plus 1, don't forget to reverse the inequality symbol and change the sign. D plus 1 is less than or equal negative 2. Take away 1 from each side. D is greater than or equal 1, or take away 1 from each side. D is less than or equal negative 3. Let's graph this. D greater than or equal 1, D less than or equal negative 3. And there's that. D greater than or equal 1 and D less than or equal negative 3. And then to wrap up the video, let's talk about solving a real-life problem. Now, first of all, here's another vocabulary word, and we've already kind of learned this in the first chapter. The absolute deviation of a number x from a given value is the absolute value of the difference of x and the given value. And when you read that, you might be like, well, that seems complicated. You've already learned this. I taught it in chapter 1. Absolute deviation means margin of error. You remember me saying the number here outside and on the other side of the equals, that's called the margin of error. So absolute deviation means margin of error. And then x minus the given amount or the target amount. So this little absolute deviation formula is just saying if you take x minus the given amount or the target amount in absolute values, it should equal the margin of error. Just remember, this term, absolute deviation, means margin of error. That will help you set these up. So when you read this question, you are buying a new computer. The table shows the prices of the computer in a store advertisement. You are willing to pay the mean price. Think about that. That means I'm willing to pay the average price with an absolute deviation. That means margin of error. So I'm willing to pay the average price with a margin of error of at most $100. Okay, so in other words, if I take the average price, I want the margin of error to be less than or equal to $100. So I'm going to have to use this little thing here, okay? First of all, let's get the average price. If I add all these numbers up, and there are 10 of them, I get 6,640. If I divide by 10, that's $664. That's my target price. That's what I want. That's what I want to pay. I want to pay the mean price. So that's my target amount. So x minus 664 in absolute values should be less than equal 100. So I want to pay $664 for this computer, but I'm willing to have a margin of error of 100 either way. All you need to do is solve this. So you're going to write your two equations. It's an and question. You'd have x minus 664 is less than equal 100, and x minus 664 is greater than equal negative 100. Solve each of those, and you have your answer. So you should be getting 564 and 764. That's the price range I'm willing to pay for the computer. I think I'm going to pause the video there. If you have any questions, make sure you ask during class.